You are listening to Fictional Radio Broadcast, live reports from fictional events. This broadcast is a work of fiction created for entertainment purposes. What follows is a dramatized scenario.
If you are anywhere near the Mississippi River tonight, do not go down to the bank to see what people are talking about. Do not stand on a levee. Do not walk onto exposed riverbed. And if the current beside you appears to be moving north, understand that the problem is no longer whether your eyes are deceiving you. Multiple instruments are now reporting the same thing. This is fictional radio broadcast. The Mississippi is moving in the wrong direction, and the part emergency officials cannot explain is that the ground has not shaken. Good evening. My name is Daniel Hale. It is 8:31 Monday evening. I am broadcasting from AM 1720 as part of the FRB Emergency Network. We came on the air ahead of our normal schedule because of a developing situation along the central Mississippi River. I want to establish something immediately. There has been no major earthquake. There is no severe weather system over the region. There has been no major upstream dam failure. There has been no extraordinary rainfall event. And as of 30 minutes ago, there was no official flood emergency anywhere along the stretch of river we are discussing. That is why the first reports sounded so strange. We are going to handle them carefully. I will tell you what has been confirmed. I will tell you what remains uncertain. I will not turn rumor into fact, simply because the rumor is frightening. And if our understanding changes tonight, I will tell you exactly when it changes. At 7:43 this evening, a river worker south of Caruthersville, Missouri, noticed that several pieces of driftwood had stopped moving downstream. Not slowed, stopped. He watched them for approximately 40 seconds. Then they began moving north. At 7:51, a commercial towboat operating farther north recorded an unexplained upstream drift while its engines were near idle. The pilot corrected. The movement continued. At 8:02, an automated river current station reported a negative velocity. Technicians assumed sensor error. The instrument was reset. The second reading was also negative. The third was 0. Then the station stopped transmitting. Normally, those 3 reports would not be enough to put us on emergency programming. Rivers produce eddies. Navigation sensors fail. Wind can move surface debris. Boats misread current. Equipment develops faults. But at 8:19, a second monitoring station more than 20 miles away reported the same thing, negative flow, and at 8:24, a third station did it. There is an old Mississippi navigation chart hanging on the wall beside me. It belonged to my father. He worked this river long before I ever sat behind a microphone. When I was young, he used to point at the bends on that chart and tell me something I thought was just an old riverman saying. He said people make a mistake when they live beside a river long enough. They start believing the river knows where the map says it belongs. I have been looking at that chart for most of the past half hour. At the moment, I would very much like the map to be right. The weather remains calm. Wind is light. Visibility is good. There is no thunderstorm activity capable of producing unusual river behavior. Traffic away from the immediate river corridor is normal. Most people listening tonight would have no indication that anything unusual was taking place unless they were standing beside the water. That contrast matters. There are no sirens across the entire region. There are no dark clouds on the horizon. There is no large earthquake people can point to and say, that was the moment everything changed. There is simply a river beginning to behave differently. The first physical report we can partially verify comes from a floating dock south of Caruthersville. Under ordinary current, the dock pulls consistently against its downstream mooring. Tonight that pressure weakened, then disappeared. A worker described the water around the pilings as looking almost like a lake. The Mississippi is never truly still. Even on a calm evening there is motion, surface texture, small current lines, debris drifting, pressure against fixed structures. For several minutes, those signs diminished. Then the pressure returned from the opposite direction. A second worker confirmed it. Neither reported shaking, neither heard an explosion, neither observed a bank collapse. That is important. The historical comparison, already spreading through the region, is the New Madrid earthquake sequence of the early 19th century. Historical accounts describe extraordinary disturbances on the Mississippi during those earthquakes, including temporary upstream movement and violent changes in the river. That is history. It does not prove anything about tonight, and there is an obvious problem with the comparison. The instruments designed to detect earthquakes are quiet. We have checked available regional seismic reporting. No significant event has been registered. There have been a handful of tiny background tremors of the kind recorded routinely in this part of the country, nothing remotely large enough to physically reorganize a major river. At 8:42, navigation authorities advised commercial vessels along a limited section of the Mississippi to reduce speed and monitor unusual current conditions. The instruction is precautionary. No general river closure has been issued. At 8:44, another gauge changed sign, southward flow, near zero. Then northward flow. It remained northward for 7 minutes. I want to explain why that matters. When people hear that the Mississippi is running backward, they may imagine the entire river suddenly reversing from Louisiana to Minnesota. That is not what we are observing, at least not at this stage. We are observing individual reaches of the river where measured current has changed direction, some for minutes, some repeatedly, some only at the surface. Hydrologists are checking whether a common software failure could produce these readings. If so, that would explain the instruments. It would not explain the boats. A commercial pilot has now submitted a GPS track showing approximately 600 feet of upstream displacement. His engines were not driving the vessel north. He initially believed he had entered an unusual eddy. He turned the vessel slightly. The current continued pushing him upstream. The crew used fixed lights on shore to confirm direction. This was not a reverse display. It was not a compass error. Something moved the boat north. At 8:48, all vessels in that immediate navigation reach were instructed to hold safe position where possible. I want anyone listening from the river to take that seriously. Do not assume your experience with this water is enough tonight. If you operate commercially, follow the traffic center. If you are recreationally boating, get off the river when and where authorities say it is safe to do so. Do not attempt to investigate abnormal current yourself. A river does not need to look violent to become dangerous. In fact, one of the reports arriving now describes the opposite. The water has become smooth, too smooth. We have another category of information. This one did not come from the river. A homeowner outside New Madrid reported that the water level in a private well had risen rapidly during the last hour. There has been no rain capable of explaining it. The homeowner also noticed a faint sulfur smell. That report was initially treated as an isolated groundwater issue. It may still be. A second well has now been reported with a similar rise. Then a third. 3 household wells are not enough to establish a regional pattern. But because of the river situation, emergency managers are logging them together. No one is advising people to evacuate because of well water changes. Anyone using a private well in the immediate area is being asked to report sudden changes in level, clarity, odor, or sediment. That is all. We have a brief update from Regional Geological Monitoring. No significant earthquake has occurred. No seismic sequence capable of producing major ground displacement has been identified. That is reassuring in one sense. It is deeply inconvenient in another. Because if the river current has physically reversed, something has changed the balance of the water. A river flows because of gravity. It follows a gradient. If you want water to move the opposite direction, you need to alter pressure, elevation, obstruction, or some combination of those things. An earthquake could do that. The instruments say we have not had one. A major landslide could do it locally. No landslide has been identified. A dam or navigation structure could affect levels. There is no structure in the affected reach capable of explaining the pattern being measured across multiple sites. Equipment error could explain a gauge. It cannot push a towboat upstream. That is the puzzle at 8:59. We have a physical effect with no accepted physical cause. I do not want to dramatize that beyond what it is. Science frequently begins with observations that do not fit the first explanation. Most of those observations eventually become ordinary once enough information is available. Tonight may be one of those nights. I hope it is. At 9:01, however, a fourth private well reported a rapid level increase, and this homeowner reported something else: fine pale sediment in the water. The river has now been closed temporarily to new commercial traffic through part of the affected corridor. Vessels already in the area are being directed individually. This is no longer merely a monitor and report situation for navigation. Authorities are treating the current changes as a genuine safety hazard. We have no reports of major vessel damage, no confirmed collision, no confirmed bridge strike. That is good. The difficult part is that the current is not behaving consistently. One pilot reported northward flow. Another, several miles away, reported almost no current. A third measured stronger than normal downstream movement. That pattern matters. If the entire affected river were simply backing up behind one obstruction, engineers would expect a more coherent response. What they are getting looks fragmented. Different sections, different direction, different timing. At 9:10, one station that had reported northward flow switched south again. 7 minutes later, it went north. A technician assumed the sensor was oscillating between bad values. A visual marker at the site changed orientation at approximately the same time. The sensor may be accurate. At 9:13, several riverbank access points were closed. Please do not go around barriers. Videos are already appearing of people walking toward exposed mud where the river level has dropped temporarily. Do not do that. A falling river at one location does not mean the danger is over. If water is being displaced, the missing water has gone somewhere, and if pressure changes again, it can return. There is another reason to remain off exposed riverbed. The ground near the Mississippi is saturated sediment. After unusual groundwater movement, it may not support weight the way it normally does. Stay out. We are receiving a report from a drainage outfall now. Water is moving from the Mississippi into a channel designed to drain toward the Mississippi. Let me say that more simply. A ditch that is supposed to empty into the river is filling from the river end. That is our first confirmed reverse flow report involving infrastructure. A pump station has been notified. The larger system remains functional. But this is how a river anomaly begins affecting people who are not standing beside the main channel. Stormwater systems, wastewater systems, industrial intakes, drainage canals, agricultural pumps, all of them depend on one basic assumption. The river side is the lower side. Tonight, at least in one place, that assumption is temporarily false. It is 9:31. We have now reached the point where I can use a phrase I avoided during the first hour. Sections of the Mississippi River are flowing backward. That is confirmed. Not the entire river, not continuously, but several monitored sections have recorded sustained upstream movement, supported by physical observations from vessels and fixed structures. The event is real. What remains unexplained is the cause. The regional seismic network still shows no significant earthquake, no shock large enough to produce the kind of deformation normally associated with river reversal. I have spoken with a seismologist advising emergency officials tonight. I am paraphrasing her assessment because she is not joining us as a second voice. Her position is straightforward. If the riverbed had abruptly risen enough to force a large volume of Mississippi water backward, conventional earthquake instruments should have recorded the event. They did not. She also noted that the seismic network in this region is specifically designed to watch the new Madrid system. This is not an unmonitored part of the country. A major rupture would not easily hide. I asked whether the river data could be wrong. Her answer was that one gauge could be wrong. Several could be wrong through shared systems, but independent visual observations and vessel movement make a purely digital explanation increasingly difficult. I asked what could produce river reversal without a detectable earthquake. She did not offer a mechanism. That is the careful answer. Not impossible, not supernatural, unknown. At 9:36, the number of private well reports rose to 12. At 9:38, emergency management in another county confirmed similar calls. Water rising, cloudiness, sulfur odor. At 9:41, the first homeowner reported sand coming out of the well. Not dirty water. Sand, fine material settling visibly at the bottom of a glass. That report is being examined. At 9:43, another household reported the same thing. At 9:45, a third. This is where tonight's story begins changing. Because river current and private wells seem, at first, like separate systems, they are not. Both respond to pressure beneath and within the ground, and the ground is still not shaking. I want to explain a historical phenomenon carefully. During major earthquakes in water-saturated sediment, intense shaking can cause a process called liquefaction. Loose, wet sediment temporarily loses strength. Water pressure rises. Sand and water can be forced upward through cracks and weak points. In the New Madrid region, historical earthquakes produced widespread sand blows. Those features remain visible in parts of the landscape today. Tonight, households are reporting sand coming through wells. That does not prove liquefaction. A well can produce sediment for many reasons: pump problems, aquifer disturbance, construction, local soil movement. But we now have enough similar reports that geologists are taking them seriously. Here is the contradiction. Liquefaction requires strong ground motion. Strong ground motion should register. The instruments are quiet. I have just received an updated count. 17 private wells across several counties have reported rapid water rise. 9 reported unusual odor. 6 reported visible sediment. 4 reported significant sand. Those numbers do not mean 17 emergencies. They mean 17 independent data points. The geographical distribution is the more important detail. They form a rough band through the same region associated with the New Madrid Seismic System. At 9:54, a homeowner reported a fresh crack across a concrete floor. No shaking was felt. At 9:56, a warehouse reported that one set of doors no longer closes cleanly. No structural failure. The frames appear slightly out of alignment. At 9:58, a highway maintenance crew reported that a drainage culvert had changed slope enough for standing water to collect on the opposite side from normal. None of those observations by itself is extraordinary. Together they are beginning to describe movement, slow movement, movement too subtle for people to experience as an earthquake. I am looking at the seismic report again. No major event, no meaningful shock, yet the river is reversing, groundwater is rising, sand is appearing, structures are changing alignment. If this were happening after a magnitude 7 earthquake, every one of those reports would make sense. The fact that there has been no earthquake is becoming the most important fact of the night. We have just received information from high-precision ground instruments. This changes the situation. For the last 2 hours, the question has been how earthquake-like effects can occur without an earthquake. The answer may be that the ground is moving in a way ordinary earthquake instruments are not designed to emphasize. Several tilt and positioning stations along the region have recorded coordinated slow deformation. The movement began before the first river report. It is small, fractions of a degree in tilt, millimeters in measured displacement, but it is directional, and several stations are moving in a related pattern. There is no violent shaking, because the motion is not occurring in seconds, it is occurring over hours. The preliminary interpretation is a slow ground deformation event. I want to be cautious with terminology. Slow slip processes are known in geology. They are more commonly discussed in other tectonic settings. No one has established that tonight's event is identical to any textbook example. But the important distinction is simple. A conventional earthquake releases movement rapidly. The ground jerks. Seismometers see it immediately. Tonight, parts of the region may be changing shape slowly enough that people do not feel a shock, even though the total displacement is beginning to matter to water. That may explain the river. It may explain the wells. It may explain the cracks. It may explain why something is happening without a classic earthquake signal. But it creates a new problem. If the ground is still moving, then the river has not finished responding. Earlier tonight, hydrologists treated the river anomaly as a temporary disturbance. Now they have to consider a moving landscape. You can model water on a fixed surface. It is much harder to model water while the surface underneath it continues to tilt. Think of water spilled across a table. You can predict where it goes if the table stays still. Tonight, someone is slowly bending the table, and the Mississippi is sitting on top of it. There is another development. A survey crew has found water moving through a depression east of the current river channel. At first they suspected a levee breach. No breach has been identified. The water appears to be following an older low path across agricultural land. An abandoned river feature, possibly part of a former channel. It is narrow, it is shallow, but it is moving. The Mississippi is not simply reversing inside its banks anymore. A portion of its water may be leaving them through a route that has not carried continuous river flow in generations. That changes the safety guidance immediately. Do not rely exclusively on old flood maps. I am repeating that. Do not rely exclusively on old flood maps. If local officials issue an evacuation order for an area that you believe is outside the normal floodplain, follow the order. Tonight's water may not respect the normal floodplain. The river has begun using old geography, and at 10:09, the first road crossing that old path was closed. Emergency managers are widening the area under advisory, not because a single flood wave is moving outward, because multiple systems are responding. The Mississippi itself, tributaries, groundwater, drainage networks, abandoned channels. We have a report from another old river scar, now carrying moving water. At first it was described as ponding. A helicopter crew observed visible current. That distinction is important. Floodwater sits. A channel transports. Water is not simply accumulating there, it is going somewhere. At 10:21, engineers compared the new flow with historical terrain maps. The path follows a low corridor created by older Mississippi movement. This region is full of those scars. The modern river looks permanent on a road map. Geologically, it is not. Old bends remain in the land. Oxbows, swales, buried channels, former cutoffs, places where the river used to be. People farm them, build roads across them, put houses near them. Tonight some of those old paths are lower than they were yesterday relative to the active channel. If enough water finds them, they can become relevant again. A sheriff's deputy trying to reach one closed road stopped on a rise. His navigation system showed the Mississippi more than 3 miles west. He could see moving brown water directly in front of him. Fence posts disappeared into it. The current was heading north. The map told him there was no river there. He turned around. That may be one of the most important decisions anyone made tonight. Do not trust familiarity more than physical conditions. If your map says a road exists and you can see water crossing it, the water wins. If your GPS gives you a route through a closure, the closure wins. If you have lived beside the Mississippi for 50 years and you have never seen water in a particular field, that history does not guarantee the field is safe tonight. The old rules assumed the ground stayed where it was. The ground is moving. The rate of slow deformation appears to be increasing. I want to clarify what that does and does not mean. It does not mean a large earthquake is guaranteed. It does not mean anyone can predict a rupture tonight. Earthquake prediction does not work that way. What scientists can say is that the measured motion is continuing. Some points have risen. Some appear to have subsided. Groundwater pressure is changing across a wider area. Those differences matter to water. An inch sounds trivial when you are standing on a road. Spread across miles of river and floodplain, an inch can change where water prefers to go. At one low agricultural district, water is now moving against the normal direction of the drainage system. Pumps have been stopped because operators are concerned they may be forcing water into a higher downstream level rather than removing it. At another site, a flood control gate closed automatically when pressure rose from the riverside. The gate did exactly what it was designed to do. The troubling part is that no one expected it to need to close tonight. A wastewater system has reported backflow, a municipal outfall is under review, an industrial intake has been shut down, the river event has entered infrastructure, and infrastructure carries the event inland. You can be several miles from the Mississippi and still lose a road, a sewer, a pump, electrical service, or drinking water because those systems depend on the river behaving normally. A river city is designed around direction, intake, outflow, drain, discharge, protection, return. Tonight, some arrows on that diagram are pointing the other way. There is a new sound being reported. I want to treat this cautiously because sound descriptions are subjective. Residents near New Madrid and several nearby communities describe a low-frequency noise. Some compare it to a distant train that never arrives. Some describe a transformer hum beneath the ground. Others say they feel it through the floor more than they hear it. We do not have a confirmed single source. Industrial facilities have been checked. Rail traffic has been restricted. No weather system would account for a stationary low-frequency sound across this area. Geologists have suggested several possibilities: moving groundwater, sediment adjustment, slow deformation, infrastructure resonance. Any of those could produce low-frequency vibration. The sound itself is not evidence of something unknown, but its geography overlaps the other effects: river reversal, well disturbance, ground movement, and now sound. At 10:45, a caller several miles from the river reported every dog in the immediate neighborhood reacting at the same time. I am not going to attach geological significance to animal behavior. Animals respond to sounds and vibration humans may not notice. That is enough explanation for now. What matters is that the same low-frequency phenomenon has been reported by people indoors, outdoors, near roads, and in quiet rural areas. No one has reported violent shaking. That remains true. The most disturbing feature of tonight continues to be how much change is occurring without the familiar warning of an earthquake. The numbers have increased sharply. Emergency lines across the affected counties have logged hundreds of related reports. Again, hundreds of reports do not mean hundreds of disasters. Many are observations, well changes, road cracks, water movement, power interruptions, drainage failures. What matters is the pattern. The pattern now extends beyond the original river reach. A tributary near its junction with the Mississippi has slowed dramatically. Another has experienced temporary backflow. A third drainage system has reversed near its outlet. This is the beginning of what hydrologists are now calling a watershed disruption. That phrase sounds technical. Its meaning is simple. The Mississippi is not an isolated pipe. It receives water from an enormous network. Rivers flow into it. Creeks flow into those rivers. Drainage systems flow into the creeks. Groundwater interacts with all of them. When the Mississippi's elevation and current change, connected water can respond. If the main river stops accepting flow normally, the pressure can push back into the branches. That means an upstream community can flood, because water is moving into the river that usually drains it. It means farther from the Mississippi is not automatically safer. It means a road can flood from the wrong side. At 11:08, a drainage canal reversed for nearly 15 minutes. At 11:11, another waterway rose without local rainfall. At 11:13, low ground several miles from the main channel began filling through a network of ditches. Aerial teams are now monitoring old river channels throughout the region. The event is no longer defined by one question. The Mississippi is running backward. The new question is, what happens when the rest of the watershed has nowhere normal to go? Memphis has begun preparing for unstable river conditions. I want to be precise. There is not a citywide evacuation. There is not a wall of water moving toward downtown. There are localized riverfront closures. Industrial areas near low elevations are being monitored. Emergency crews are repositioning. Several waterfront access points are closed. Navigation through the affected Mississippi corridor is increasingly restricted. The reason is not simply high water. Levels are oscillating. One gauge drops. Another rises. A current reverses, then stops, then moves south. The danger is unpredictability. A riverfront can appear safer when the level falls. People go closer, then the water returns. A large vessel near Memphis reported unusual pressure against its mooring lines. A second observed debris moving north. A third recorded surface movement different from deeper current. That final observation is under review. If confirmed, it may indicate layered flow. Water at different depths moving differently for a time because of strong pressure gradients and channel geometry. That is unusual. It is not impossible. But every new complication makes navigation more dangerous. Commercial river traffic through a broad section is now suspended. Tow crews are securing vessels where possible. Bridge operators are monitoring impacts. Emergency agencies are asking people to stay away from the riverfront. Do not treat that as an invitation to find a better viewing point. This is not a spectacle. If the current changes direction while you are standing near a steep bank, the first visible warning may arrive too late. The slow ground movement has accelerated again. The exact numbers are being revised, and I am not going to turn preliminary millimeters into a dramatic countdown. The important part is the trend. Movement continues. Different portions of the floodplain are not moving equally. That unevenness is reshaping local slopes. A levee can remain intact while the ground behind it subsides. That creates a problem people rarely imagine. The structure may not fail. Its purpose can fail. If protected land becomes lower and water enters through another route, the levee can help trap that water. Engineers are evaluating several such locations. A bridge can remain standing while its approach road shifts. A drainage pump can work perfectly while pumping toward water that is now higher. A sewer valve can function correctly while receiving pressure from the opposite direction. This is an emergency of correct systems operating under obsolete assumptions. I think that is why it is so difficult to communicate. People understand broken things. A bridge collapses. A levee breaches. A pump fails. Tonight, some things are still working. The landscape they were designed for is not. We have one road whose grade changed enough that water now collects on the opposite shoulder. We have a drainage structure carrying water inland. We have an intact levee protecting ground that may no longer be the highest protected surface. We have navigation charts showing a deep channel while water begins moving through fields somewhere else. The systems are not necessarily wrong. Their world is. I need to update the station situation. We remain operational. Commercial power flickered twice during the last 15 minutes. We have transferred critical systems to protected backup. Our generator is ready. The transmitter is stable. There is no immediate threat to this building. However, a stormwater channel within the wider station area has begun flowing opposite its normal direction. Public Works confirmed the reversal. That water ultimately connects through a series of drainage systems toward the larger river network. It is not flooding us. Not now. I am mentioning it because this is the first confirmed effect close enough to the station that our own staff could reach it quickly. We are not going. There is no reason to stand beside an abnormal channel at midnight to prove something instruments have already confirmed. I am giving you the same advice. You do not need to see it yourself. At 11:45, the river monitoring map updated. A technician here put it on the larger studio display. The affected region no longer looks like a line along the Mississippi. It looks like a branching pattern. River, tributaries, old channels, drainage corridors, subsidence areas. Some zones are wet. Some are predicted to become wet. Some are simply being marked because their elevation changed. The shape crosses the river repeatedly. That is a new category of risk. There may be no single flood front. Water may appear in connected low areas ahead of what people think of as the main river. If you are ordered to leave, do not wait for water in your yard. Your road may flood first. That is how people become isolated. Dry house, flooded exit, no time left. We want to remind listeners that you are tuned to Fictional Radio Broadcast, continuing to monitor this developing situation. The latest civil advisory has changed language again. Earlier, officials asked residents to remain alert. Then they advised preparation. Now residents in several specific low-elevation corridors are being instructed to relocate before visible flooding begins. That is a major shift. Before visible flooding begins. Authorities no longer trust familiar water cues. If your local emergency management office tells you to relocate, do it. Bring necessary medication, identification, water, a flashlight, a battery radio, essential items only. Do not delay because you are trying to predict whether the river will actually reach you. Nobody has a stable river model tonight. There is also an updated instruction regarding exposed riverbed. Stay off it. Several sections where water withdrew earlier are unstable. One responder described broad mud cracking. Another reported bubbling water rising through exposed sediment. Groundwater pressure is changing from below. A bank that appears solid can collapse. A mudflat can liquefy. The river can return. At 11:56, responders near one exposed section heard a sustained rushing sound. They moved uphill. Several minutes later, water re-entered the channel from upstream. Fast. Carrying branches, pieces of dock, empty tanks, and other debris. No injuries were reported. The lesson is simple. If the Mississippi disappears from where you expect it to be, do not follow it. We have had the first clearly felt seismic event of the night. It was small. I felt it here. A short vibration. Glass moved. The microphone arm shifted slightly. Preliminary instruments are registering it. Magnitude estimate is still under review, but it is nowhere close to the catastrophic earthquake people have feared. What makes it important is timing. Slow deformation has been occurring for hours. Now we have a conventional seismic signal. Geologists are trying to determine whether this is an ordinary small earthquake within an active sequence, or evidence that part of the slow movement has begun transferring into brittle rupture. No one is predicting a major earthquake. Do not interpret the event that way. But emergency agencies have increased earthquake readiness. Bridges are being inspected again. Rail traffic is being held. Some older masonry buildings are being evacuated locally. The Mississippi responded almost immediately at 2 nearby gauges. One reversed. One surged downstream. A third remained still. That inconsistency is becoming defining. There is no longer one Mississippi behavior. We are beginning to treat individual reaches almost as separate systems. The old channel flow east of the main river has widened. Aerial observation now shows continuous water across several connected lowland areas. Some sections are only shallow sheet flow. Others are beginning to cut defined banks into soft soil. One road has washed out. A second has water across it. A third remains open but is being closed proactively. The path appears to connect with an existing creek farther north. If water continues moving into that creek, erosion may enlarge the route. This is how a temporary overflow can become a channel. Water finds a low path. The path erodes. The lower path attracts more water. More water causes more erosion. At some point, the new route stops being an accident and begins competing with the old one. Engineers are not saying that has happened yet, but they are now explicitly considering channel capture. That is the first time tonight we have heard professionals discuss the possibility that part of the Mississippi could establish a lasting alternate path. My father's chart is still beside me. There is a pencil note in one corner, river subject to change. I had forgotten about it. He probably wrote it as a reminder about navigation conditions. Bends migrate, sandbars move, channels shoal. But tonight those 4 words look less like a note and more like a warning. River subject to change. The station has lost commercial power. We are on generator. If you are hearing a slight change in the signal, that is why. The carrier is stable. Our studio is functional. We have enough fuel for continued operation. Telephone service is intermittent. One network connection remains stable enough to receive emergency data. The low-frequency sound reported earlier is now faintly audible here. I want to be careful. There are generators running, ventilation systems, emergency vehicles outside. A building contains many possible sources of vibration, but our engineer noticed the sound before I mentioned it. He describes it as a low, steady resonance. It does not rise and fall like traffic. It does not pulse like machinery. We are monitoring it. The floor is not shaking, at least not in the conventional sense. A hairline crack has appeared in a utility corridor. That may have existed before tonight. We are checking older building photographs. The municipal water briefly turned cloudy. It cleared after several minutes. Again, there are ordinary explanations for both, but given regional conditions, we are not dismissing them. We have moved some equipment off the lowest floor. The decision is precautionary. No evacuation order has been issued for this facility. If one is issued, I will tell you. The event has expanded into the lower portions of additional tributary systems. Emergency hydrologists are now using 3 categories: main channel reversal, tributary backwater, new or reactivated surface flow. Main channel reversal is what began tonight, the Mississippi moving north where it normally moves south. Tributary backwater is the Mississippi pushing against rivers and channels that normally empty into it. New or reactivated flow is water using places outside the modern river system. Old channels, depressions, drainage corridors, floodplain scars. Those 3 effects can overlap. That is why the maps are becoming difficult to read. One location may be threatened from the existing Mississippi, another from a tributary, another from groundwater, another from a channel that did not exist as flowing water this afternoon. Emergency GIS teams are producing updated maps constantly. They are outdated almost immediately when new elevation or water data arrives. A state official has asked responders to treat standard flood maps as reference documents, not guarantees. That wording is extraordinary. Flood planning depends on maps. Tonight, maps are becoming historical documents while the event is still happening. At 12:48, a highway patrol unit reported a road completely cut by moving water. Their digital map still showed uninterrupted pavement. The GPS position was accurate. The map beneath it was not. Technology knew exactly where they were. It did not know what was there. We have another seismic event. This one was stronger. The studio moved noticeably. I am staying at the microphone. Preliminary magnitude 5.6. Location within the wider New Madrid region. No major structural collapse confirmed. Power outages increased immediately. Several bridges closed automatically pending inspection. The generator remained stable. The strange part is what the river did. At one station, northward flow increased. At another, the current snapped south. At another, the level rose while measured current nearly vanished. Hydrologists are no longer attempting to describe the entire affected Mississippi with a single directional arrow. They are dividing it into segments. I have the newest operational map. Some sections are marked north, some south, some unstable, some unknown. One section is marked diversion. That is the new channel. I have spent years reading weather radar, road maps, flood maps, earthquake maps. I have never seen a major river represented as a chain of contradictory arrows. But that is what we have tonight. There may no longer be one useful answer to the question, which way is the Mississippi flowing? Memphis riverfront operations have moved into a higher emergency posture. Again, there is no citywide evacuation. Several low industrial and waterfront areas remain restricted. Emergency crews are relocating equipment. Public access is closed across multiple riverfront points. Water levels continue to oscillate. One section fell rapidly enough to expose broad mud, then rose. Another continues higher. A moored structure broke free and was recovered farther upstream. That detail has now been verified. Upstream, a large floating object released near Memphis moved north. At the same time, a deeper current measurement nearby suggested strong southward flow beneath part of the surface. Different layers, different directions. The river is becoming hydraulically complicated enough that visual observation alone cannot tell crews what the water will do. Navigation remains suspended. This is no longer about keeping boats on schedule. It is about keeping them from becoming moving hazards. A barge tow weighs too much to experiment with an unstable current. Several crews have been removed from non-essential vessels. Fuel and chemical facilities near low riverfront locations are securing operations. That is precautionary. No major hazardous release is confirmed. We have a new groundwater issue. Monitoring wells farther from the Mississippi are rising. Some are cloudy. One overflowed. The location is outside the initial cluster. That means subsurface pressure changes are spreading or being detected across a larger zone. Geologists caution that groundwater systems do not respond uniformly. A rise does not necessarily mean land directly beneath the well is moving. Pressure can travel through connected sediment layers. That may explain some of the timing contradictions from earlier tonight. It may also explain why water is appearing in low areas before surface flow reaches them. A farmer reported water bubbling through a field. No rain, no nearby overflowing ditch. The water first appeared in several small patches. The patches joined. Within half an hour, a shallow sheet was moving toward a low road. That road is now closed. This event is developing from above and below. River water moving sideways, groundwater moving upward, drainage systems moving backward, and beneath all of it, the land continues adjusting. The rate of measured deformation has increased again. I need to be disciplined here. There is no reliable method to tell you that a large earthquake will occur at a particular time. No scientist tonight can responsibly give you a countdown. Slow movement can continue. It can stop. It can redistribute. It can transition. The uncertainty is real. But the fact that movement is accelerating is why earthquake precautions have expanded. If you are in the designated New Madrid risk area, secure heavy objects if you can do so safely. Keep shoes nearby. Have a flashlight. Keep your phone charged when power is available. Do not sleep beside unsecured masonry or glass. Know how you would leave your building after shaking. Do not drive onto bridges merely to leave unless local authorities direct you across them. A poorly chosen evacuation route can create greater risk than sheltering appropriately. The event tonight is complicated because earthquake safety and flood safety can conflict. Higher ground may mean crossing a bridge. An open area may be near a river. A low road may be clear when you leave and underwater when you return. Follow local emergency instructions rather than generic rules whenever possible. The active channel east of the river is now more than 20 miles long when measured through connected segments. I need to qualify that. It is not 20 continuous miles of a broad navigable river. Some stretches are flooded fields, some narrow channels, some old creeks, some abandoned Mississippi scars. But the water connection can now be traced across that distance. The current is strengthening. A farmhouse on slightly higher land has water moving on two sides. The residents evacuated earlier. A grain storage area is isolated. One county road no longer exists across a section where the new flow has cut through the embankment. Aerial crews describe fencing extending into open water, street signs standing in current, utility poles surrounded. Things that belong beside roads now appear to stand beside a river. This is one of those moments where language begins lagging behind geography. Do we call it floodwater, an overflow, a diversion, a channel, a river? Engineers are using active channel because it describes what the water is doing without pretending to know whether it will remain. That may be the best phrase available. I need to tell you what is happening inside this station. The crack in the utility corridor is wider than it was earlier. Not dramatically, but enough that we can confirm it is changing. The water from one tap has turned cloudy again. There is fine sediment at the bottom of a white cup. Our building is not on a private well. The municipal system relies on regional groundwater. That does not prove direct fault movement beneath us. It does tell us the same groundwater disturbance affecting other areas has reached the supply system here. At 144, the floor shifted. Not shaking. A slow lateral sensation. My chair moved slightly. The overhead fixture swayed. The movement lasted perhaps 3 seconds. The seismic system registered only a weak event. Nothing like the physical changes implied across the region. The low-frequency sound is louder. I can hear it beneath the generator now. It is not dramatic. That makes it worse. A constant low strain somewhere below the ordinary mechanical noise of the building. Our engineer wanted to inspect the transmitter base. I told him not to. We can lose equipment. We cannot replace people. We are staying inside unless emergency management instructs us otherwise. The signal remains stable. A new technical assessment has just been distributed. The Mississippi in the affected zone is being described as hydraulically segmented. That does not mean the river has physically broken into disconnected pieces. It means different reaches are responding to different local gradients. One reach flows north, one south. One is nearly still. One is losing water into a new channel. One receives tributary backflow. There is no longer a single directional state. Think of the Mississippi not as one river for the next few hours, but as a chain of connected water bodies arguing over elevation. That description is mine, not the engineer's. But it captures the problem. Water is searching for the lowest route. The lowest route keeps changing. Some of that change is due to ground deformation, some to erosion, some to pressure, some to temporary blockage, and every gallon that enters a new path alters the next decision the water makes. The system is now changing itself. A new channel erodes. Erosion lowers it. Lower ground takes more water. More water increases erosion. That can turn a temporary diversion into a lasting one. At the same time, an old channel losing water can drop rapidly, exposing unstable banks and disrupting facilities that depend on river access. One port facility now has significantly less water at its normal dock face than it had earlier. A few miles away, farmland is carrying current. Those two facts belong to the same event. The river is not simply getting larger, it is redistributing. There is a temporary lake forming in a broad subsided area. Aerial teams have confirmed water spreading across low agricultural land and several road corridors. The basin appears to have dropped relative to surrounding terrain. Water entering it is not draining efficiently. Some comes from surface flow, some may be groundwater, some arrives through old channels. The result is a growing body of water where no lake existed this morning. That comparison to the historical New Madrid event will be unavoidable. The earlier earthquakes in this region permanently changed parts of the landscape. Tonight, we may be watching another landscape change while people are still inside it. But there is one critical difference. Historical retellings compress events. They turn chaos into a sentence. The river ran backward. A lake formed. The ground opened. Tonight, listening in real time, you hear the part those sentences hide. Nobody knows which report matters at first. Nobody knows whether the road that is open now will be open in 20 minutes. Nobody knows whether the water falling in one place means relief or danger somewhere else. Nobody knows whether temporary means 10 minutes or 10 years. That uncertainty is the real emergency. We have more than 3,000 public submissions across the wider response network. Again, these are not 3,000 casualties. They include photographs, road reports, utility disruptions, water observations, well changes, requests for assistance. The language people are using is becoming useful. Field has current, drain running backward, water behind house, road became creek, river missing, map wrong. Those phrases sound informal. Emergency analysts are mapping them because they repeat. One report from a family sheltering on higher ground says they can hear moving water in darkness from 2 different directions. Their home is dry. Their driveway is not. They evacuated before the road closed. Another household remained because their property had never flooded. The access road behind them is now under moving water. Rescue coordination is underway. That is why officials keep repeating the same instruction. Do not use past flood history as your only guide tonight. This is not a conventional rise of the Mississippi within its familiar channel. The strongest earthquake of the night has just occurred. Stay with me. The building moved hard. The lights are out except emergency power. The generator is still running. Objects fell in the hallway. I am at the desk. The transmitter status is checking now. Carrier is present. We are still on AM 1720. Preliminary seismic estimate is magnitude 6.7. That number may change. The event was centered within the wider New Madrid Zone. This is the first earthquake tonight large enough to produce serious regional damage. If you are in the affected area, expect aftershocks. Check for immediate hazards. Fire, gas, damaged walls, broken glass, downed electrical lines. Do not use elevators. If your building is damaged and you can exit safely to an appropriate area, follow local guidance. Do not move automatically toward the river. The river itself remains dangerous. We are receiving automatic bridge closures, rail lines halted, power outages expanding. Emergency channels are saturated. Please use emergency numbers only for immediate threats. I need to check river information. One moment. The new readings are arriving. The Mississippi did not simply reverse harder. The pattern fractured. Northward flow increased sharply in one reach, another reach turned south. The active diversion channel rose. A tributary gauge jumped. A drainage basin filled. And one main channel gauge dropped so rapidly, engineers believe water is leaving that section faster than it is entering. This earthquake did not restore the old logic. It accelerated the new one. The river map has changed again. I am looking at it now. There are sections of the old Mississippi where water is still moving north, sections where it is moving south, a broad area where velocity cannot be treated as stable. And the eastern diversion continues expanding. The most disturbing new feature is that the diversion is beginning to carry enough water to reduce levels in the old channel nearby. That is how a river changes course. Not because the old river decides to stop, because another path becomes easier. A hydrologist working with emergency coordination has made it clear that no one can yet say whether this will become permanent. The earthquake may have changed elevations again, sediment may block the new path, the old channel may recapture flow, water levels may fall, but the possibility is now being openly modeled. By daylight, sections of the Mississippi may occupy a materially different channel from the one shown on current maps. That sentence would have sounded absurd at 8:30. At 2:31, it is operational planning. I am going to speak directly for a few minutes. Not because the broadcast is ending, because some of you are listening under conditions very different from the room I am sitting in. Some are in shelters. Some are in parked cars. Some are in houses without power. Some are listening on small battery radios while trying to decide whether the water outside is getting closer. You do not need to understand the entire Mississippi River system to make the next safe decision. If a road is closed, do not use it. If water is crossing pavement, turn around. If you have been told to relocate, relocate. If you are in a shelter, remain there until authorities say otherwise. Do not return because shaking stopped. Do not return because the river level fell. Do not assume a dry yard means your exit remains open. Do not walk onto new mud. Do not approach a new channel. Do not stand on a bridge to watch the water. Those are simple instructions, because tonight the science is not simple. We do not yet know whether the slow deformation triggered the earthquake or whether both reflect a larger sequence. We do not know how much land movement is permanent. We do not know how the river will redistribute when the strongest aftershocks end. But moving water does not require a complete explanation before it can kill you. Treat it accordingly. The water in our lower parking area has begun rising. It is not coming from rainfall. There has been no rain. It is coming through storm drainage. A system built to remove water from this property is delivering water into it. The level is shallow. Only a portion of the lot is affected. The building remains dry. We have moved additional equipment. The generator fuel remains secure. Our engineer has checked the secondary exit. It is clear. The studio is safe for the moment. I can see the water on a security monitor. It is not rushing. It is not a dramatic flood. It is simply spreading slowly across pavement. That may be the image I remember most from tonight. A drain functioning backward. A perfectly ordinary piece of infrastructure quietly admitting that the world it was designed for no longer exists. The low sound beneath the building continues. The crack in the corridor has stabilized for the last 10 minutes. That is good. I am no longer comfortable calling any 10-minute trend good news, but I will call it stable, for now. The eastern horizon is beginning to lighten. Aerial crews are getting their first useful low-light views across wider sections of the region. The images are incomplete. Power failures create large dark areas. Some aircraft have been diverted for rescue work. Cloud and haze obscure portions of the ground, but the broad pattern is becoming visible. The old Mississippi is still there. Let me begin with that. The river has not disappeared. It has not reversed from the Gulf to Minnesota. It remains a vast connected river system. But within the central affected zone, it no longer occupies one stable hydraulic state. There are broad mudflats where water withdrew. There are flooded areas where ordinary flood maps predicted no immediate water. There are tributaries backed up. There are temporary lakes. There are old river scars carrying flow. And there is one active diversion cutting through farmland far enough from the modern channel that emergency maps now show two significant water routes, one familiar, one new. From the air, the new path is not neat. It disappears into flooded fields, narrows between raised areas, uses a creek, crosses an old channel, widens again, but it is connected, and it is moving. One survey pilot reported seeing road center lines disappear directly into brown water. A few miles farther on, he saw an old dock along the Mississippi standing beside exposed mud. That is the story in two images. A road where there is now water. A dock where there is not. The final expert assessment available to us tonight is cautious. The earthquake sequence and preceding slow deformation appear to have altered local elevation enough to destabilize portions of the Mississippi system. Groundwater pressure and sediment failure likely amplified the effects. Abandoned channels provided alternate routes. Tributary backwater spread impacts beyond the main river. The major earthquake further modified the landscape before the system could settle. That explanation is broad enough to account for much of what we have observed. It still does not explain every timing discrepancy. Several distant gauges changed earlier than the best models predicted. Some groundwater responses began before expected. One section of old channel activated with no obvious surface connection until later. Those anomalies may have ordinary explanations once data is reconstructed. Clock errors, subsurface pathways, unmeasured deformation, communication delay, incomplete elevation data. Emergency science is messy. The responsible answer is not that something impossible happened. The responsible answer is that the complete mechanism is still being assembled. What we do know is extraordinary enough. The Mississippi ran backward again, and then that stopped being the most important thing it was doing. The temporary lake north of the original zone continues rising slowly. Several structures remain isolated. Rescue teams are working from higher routes. The new eastern channel has increased flow since the 6.7 earthquake. The old Mississippi beside it has decreased. If that relationship continues, engineers may have to consider whether a more significant channel shift is underway. No declaration of permanent course change has been made. I want that clear. But some maps are already being marked provisional. Road maps, flood maps, navigation maps, utility maps. For the affected corridor, all of them depend on survey work that has not happened yet. There is a phrase appearing repeatedly in the newest planning documents. Pending resurvey. Bridge elevation pending resurvey. Channel alignment pending resurvey. Road grade pending resurvey. Levee relationship pending resurvey. That is how a landscape becomes unfamiliar administratively, not with a dramatic announcement, with the words pending resurvey beside things everyone thought were fixed. Our parking lot water has stopped rising. For 6 minutes it remained still. Now it is moving back toward the drain, the correct direction, at least here. Our engineer looked at the camera, then at me. Neither of us said anything for a moment. I think both of us had the same reaction. Relief followed immediately by suspicion. We have spent the night learning that the river can reverse twice, a drain can reverse twice, a gauge can return to normal and leave again. Stillness is not resolution. Direction is not permanence. We will keep monitoring it. The generator remains operational. Some commercial power has returned several blocks away. Not here yet. The low-frequency sound is weaker. It has not disappeared. The strongest aftershocks have become less frequent during the last half hour. That is encouraging. No all clear has been issued. I took my father's chart down from the wall. It is on the desk in front of me. The paper is worn at the folds. The river is printed in blue. There are depth marks, navigation lights, bends, old annotations, a few pencil corrections in my father's handwriting. When I was a child, I thought a map was a picture of where things were. Later I learned that navigation charts are closer to agreements. This is where the channel was when it was measured. This is where the safe depth was when the survey boat passed. This is where the bank was before the next flood. A map is confidence printed on paper. Useful confidence. Necessary confidence. But temporary. My father understood that. That is why he wrote rivers subject to change. I have read those words thousands of times without thinking about them. Tonight they are the most accurate information on the chart. The first daylight image of the active eastern channel has arrived. I wish I could show it over radio. I will describe it. The foreground is farmland. Rows are still visible beneath shallow, muddy water. A fence runs from dry ground into the current and disappears. Beyond that is a wider brown channel, cutting diagonally through what was a field. Trees line part of the old depression. The water turns there. In the distance, you can see raised ground and several buildings. They are intact. They look ordinary. That is what makes the image unsettling. Nothing about the buildings tells you a river is supposed to be there, because yesterday it wasn't. Several miles west, another image shows the modern Mississippi. Water has pulled away from part of the bank. A floating dock is tilted. Mud stretches between the dock and the active water. There is no dramatic canyon, no enormous empty riverbed, just enough difference to make the place wrong. The new channel has water. The old channel has less. The transition between maps may already be underway. Emergency officials are preparing for a day focused on rescue, inspection, and survey. That last word may define what comes next. Survey. Before bridges reopen, survey. Before roads reopen, survey. Before people return to some low areas, survey. Before navigation resumes, survey. Before anyone confidently says where the river's deepest channel now lies, survey. The earthquake danger remains. Aftershocks are expected. Water remains unstable. Some levees are under stress. Some drainage systems remain reversed. Utilities are damaged across the broader area. Stay with local emergency instructions. If you have evacuated, do not return, simply because daylight makes conditions look understandable. Daylight will show us more. It will not automatically make the ground stable. There is one final river update before I close this continuous segment. The main channel near New Madrid is moving south again at one monitored station. That is the direction people have been waiting to hear all night. South, normal. But several miles away, the diversion channel continues north. Another section of the Mississippi remains unstable. A tributary is still backed up. The temporary lake remains high, so I cannot tell you the Mississippi has returned to normal. There may not be one normal to return to yet, and I think this is where the phrase, Mississippi runs backward, becomes inadequate. That phrase suggests a river with two options, forward, backward. Tonight the Mississippi found more than two. It stopped, it reversed, it surged, it split its behavior between reaches, it pushed into tributaries, it entered old channels, it came out of drains, it disappeared from one bank and appeared beside roads miles away. It reminded everyone living along it that southward flow is not a promise. It is a consequence of the shape beneath the water. Change the shape. Change the river. If you are listening from an affected community, keep your radio nearby. If local officials issue specific instructions, follow them. Stay away from damaged riverbanks. Stay away from exposed riverbed. Stay away from newly formed channels. Do not cross moving water. Do not assume familiar roads remain safe. Do not assume a bridge is usable because it is still standing. Do not assume a levee is functioning normally because it has not breached. And do not assume the river is where your map says it is. I want to say something else before we close. For most of the night, I have tried to separate facts from fear. That remains the job. But being calm does not require pretending something is small. This is not small. People will wake this morning and find roads missing, fields underwater, wells filled with sediment, homes isolated, docks beside mud, waterways flowing the wrong way, and in at least one part of the floodplain, they will find moving water where the Mississippi did not exist when they went to bed. The maps will be redrawn. Engineers will measure everything. Geologists will study the deformation. Hydrologists will reconstruct the current. There will eventually be clean diagrams explaining pieces of tonight. There will be arrows, cross-sections, elevation profiles, models. There will be a version of this event that fits on a page, but none of those pages will capture what it was like at 8:30 when the first worker watched a branch stop in the Mississippi, or at 9 o'clock when instruments insisted there had been no earthquake, or when sand began coming out of wells, or when the ground started moving too slowly to feel, or when a deputy found a river 3 miles away from where the map said it should be, or when water began coming out of the drain behind this station. Those are the moments people will remember, the moments before the explanation caught up. The low sound beneath the station is still present, much weaker now, but present. The crack in the corridor has not changed for nearly an hour. Water in the parking lot continues draining. Our signal remains stable. The eastern sky is brighter. I can see enough through the studio window now to make out the rooftops beyond the road. For the first time tonight, morning feels real. That does not mean the emergency is over. There is no all clear. There may not be one for some time. My father's chart is still open in front of me. The Mississippi on that paper runs south in one clean blue line. Outside this building, the real river is doing something more complicated. I think my father would have understood that better than I did. He never trusted the line more than the water. This is Daniel Hale, AM 1720, FRB Emergency Network. You have been listening to Fictional Radio Broadcast, live reports from fictional events. The sun is coming up over the Mississippi Valley. In some places, the river is moving south again. In some places, it is not. And somewhere east of the channel printed on every map in this studio, brown water is moving through a field that did not have a river in it yesterday. Our microphone will remain open. The transmitter is still carrying. The sound beneath the station has not completely stopped. The Mississippi is still moving. We are still here. For now.